What's up guys, welcome back to another video here at Achieve Academy, and today we will be going through indices. Our learning outcomes for today's lesson is to understand what indices are and how they will be asked in exams and how to answer them. So, indices is a small floating number that appears after a number or letter. Indices show how many times a number or letter has been multiplied by itself. For example, a squared means a times a. In today's lesson, we will focus on multiplication and division of indices, along with writing numbers in their index form. For example, 27 can be written as 3 cubed. The index law for multiplication only works if the base numbers are the same. For example, in the calculation, 2 squared times 2 cubed, the base number of 2 is the same. When multiplying indices, if the base values are the same, the expression can be simplified by adding the indices. The index law for multiplying still applies even when the indices are negative. For example, in this equation, y to the power of 5 times y to the power of 4 equals y to the power of n, we would simply add 5 and 4 to give us n equals 9. As usual, I've taken some maths exam questions from Maths Genie for you to practice. I will leave the link down below in the description if you want to go to Maths Genie yourself. Also, as a little hint before we start, on 2b, we have an indices and an indices outside the bracket. When you see this, you simply times the indices together instead of adding them. Starting off, 1a asks us to simplify x to the power of 8 times x cubed. Here we use simple addition for 8 and 3 to get x to the power of 11. 1b asks us to simplify 5y all cubed. Here we cube the 5 and we cube the y, leaving us with 125y cubed. 1c asks us to simplify w to the power of 7 divided by w to the power of 4. As many of you may have noticed, division is the opposite of multiplication, so we simply minus the indices instead of adding them, leaving us with w cubed. On question 2a, it asks us to simplify a to the power of 9 times a to the power of 4. As the base letter of a is the same, we use addition. 9 plus 4 equals 13, giving us a to the power of 13. As I stated before, on question 2b, we are asked to simplify a bracket with an indices outside. When you have an indice such as 3 outside, you use the indices against the bracket. As 3 is outside, we will cube the bracket individually. 4 cubed equals 64, b squared cubed equals b to the power of 6, and c cubed is just c cubed, giving us the final answer as 64, b to the power of 6, c cubed. On 2c, we have to simplify d to the power of 9 divided by d to the power of 4. As we did in question 1c, we minus 4 from 9, giving us 5. So our final answer would be d to the power of 5. In your exams, you will also be asked to find the reciprocals of numbers. The reciprocal is a term that you use to times any given number to equal 1. The negative reciprocal is a term that you use to any given number to equal negative 1. For example, a quarter times 4 gives us 1, but a quarter times negative 4 gives us negative 1, meaning our negative reciprocal of minus 4 is a quarter. Here are some more exam questions for you to have a try. Pause the video, have a go, and unpause when you're done. So, part A asks us to write down the value of 5 to the power of negative 3. As the indices is negative, we know we must put it in fraction form. 5 cubed equals 125, so our answer equals 1 over 125. Part B asks us to write down the value of 5 to the power of 0. If you do not know, anything to the power of 0 equals 1, so our answer is just 1. Question 2 asks us to find the value of x when we have 1000 to the power of 4 equals 10 to the power of x. To find the value of x, we must first put 1000 to the power of 4 in the form of 10 to the power of 7. we can rewrite 1000 to 10 to the power of 3. As the base numbers are the same, we can times 3 and 4 to get x equals 12. If you do not know your cubed and squared numbers, I highly advise learning them, as they will come up on all your exams. On exams, they like to ask you a bunch of indices questions together. Here are 2 examples of what have been on previous past papers, so you know this is what you will be asked. Have a go at them, pause the video, and unpause when you completed them. In part A, we are asked to simplify 9p cubed times 2p to the power of minus 2. First, we times our numbers together. 9 times 2 equals 18. And as our base letters appear the same, we simply minus 2 from 3, leaving us with just 1. P to the power of 1 is just p, so we leave our final answer as 18p. In part B, we are asked to simplify 5x cubed y squared, all bracketed, to the power of 3. Here, we simply cube each individual part of the bracket separately, leaving us with our final answer 125 x to the power of 9, y to the power of 6. In part C, we are asked to find the value of y in the equation p cubed times p to the power of 5 equals p to the power of 12 times p to the power of y. We can rewrite this as p to the power of 8 equals p to the power of 12 times p to the power of y. To get from 12 to 8, we minus 4, leaving us with our final answer, y equals minus 4. In part A, we are asked to simplify 5c squared d cubed times 2d. Here, we simply times the whole equation by 2d, leaving us with 10c squared d to the power of 4. Part B asks us to write 64 times 4 to the power of 5 as the power of 4. If you didn't know, you can write 64 as 4 cubed. As our base numbers are now the same, we simply add 3 and 5 to get 8, leaving us our final answer 4 to the power of 8. In part C, we are asked to simplify p cubed times p to the power of 5 bracket squared. As it is inside the bracket, we must first times 5 by 2 to get p to the power of 10. And then as our base letters are the same, we use simple addition to get p to the power of 13 as our final answer. Time to finish off the video with our hardest question. Have a go, pause the video and unpause when you're done. So, we are told to simplify 10p cubed q to the power of 5 r divided by 4p cubed q to the power of 6. First, we will separate the fraction into 2 separate bits to make our lives easier. Here we can separate 10p cubed divided by 4p cubed and q to the power of 5 r by q to the power of 6. Here we use simple division and we divide down. 5 over 2 is the simplest form of 10p cubed divided by 4p cubed, and q divided by r is the simplest form of q to the power of 5r, q to the power of 6. We then simply times them back together to leave our final answer 5r divided by 2q. And that is how easy indices are. Thank you very much for watching. If you stick around to the end, please like and subscribe. It helps the channel out massively, as it helps me keep producing these videos for you. I will see you in the next one. Enjoy.